Where you see that phrase, rational expressions, what that means, typically what rational expressions means, fractions with variables. Okay, that's what rational expressions typically mean, fractions with variables. Now, in the video that you watched, one of the big reasons I like that video is because he does a good job of explaining the difference between monomials and polynomials of 2 or more terms. He calls them loners and groups. And one of the biggest common mistakes that you guys will make is you'll try to cancel a loner with part of a group. Okay, loners can be canceled with loners, groups can be canceled with groups. That's the only way it works. If you try to break a group apart and cancel it with a loner, it's not going to work. And you're going to mess it up, and I don't want you to do that. So if you can keep in mind that monomials are loners, any other polynomial that has 2 or more terms is a group. Okay? So, basically what you're going to do is we're going to turn all division problems into multiplication problems. Because once it's multiplication, then we've got all these numerators on top and all these denominators on bottom that we could actually combine into one giant fraction. And once we have one giant fraction, we can cancel tops and bottoms. So we want to eliminate division problems, make them multiplication problems. And the way we're going to do that is keep, change, flip. Okay, we're going to keep the first fraction, change the sign from division to multiplication, and flip the second fraction. Okay, once we have that, you're going to factor completely. Now, if it's a problem with a bunch of loners, you don't need to do any factoring. When you have binomials, trinomials, polynomials with more than 3 terms, you're going to want to factor those so that you can cancel some groups. And once you've factored completely, then you can cancel tops with bottoms. So, again, we're trying to turn everything into a multiplication problem if it's not already. If we just have a fraction, we don't have to worry about that because we can just cancel tops and bottoms. Questions on any of that? So let's look at this first one. Multiplication problem already, so I don't have to worry about changing signs or anything. I have 4 loners, okay? 4 monomials. So I'm free to cancel tops with bottoms. No factoring needs to take place. So go ahead and work on that one. See what you come up with. So keep in mind, you can cancel any tops with any bottoms because the reality is, in multiplication of fractions, I can actually combine this all on the top, and I can combine this all on the bottom, and make it one giant fraction. That's what multiplication of fractions really is. I don't actually have to multiply them together. In fact, I would not recommend doing that. I would try to cancel stuff first before multiplying it all together. And the reason is when the numbers are smaller, it's easier to recognize the factors of those numbers. When you multiply those numbers together, sometimes it's a little harder to see all the factors because the numbers get so large, the options increase in terms of what factors there could be. So this is the reason why we can cancel tops and bottoms right here. Even though I have sort of separate fractions. I can cancel up and down, I can cancel crossways too. But the reason I can do that is because of this. Okay? Because it's really just one giant fraction. So take another minute to finish that one up and we'll see what you ended up with. Let's go through this one and let's see how you approach it. Okay? Now, I would work with the numbers first. That's how I like to do it. You don't have to do it that way, but that's how I like to do it. So, first of all, I have 6 that goes into 18 3 times. Alright? I also have 3 that goes into 21 7 times. So I've eliminated the 6, and now I've eliminated the 18. Because you can eliminate tops and bottoms. 3 goes into 21 7 times. Now, You didn't have to do that one. You could have also said, all right, there's a 3 that goes into 15 and 21 and had a 7 there and a 5 here. That's okay. Yeah.
Could you have done for the 6 over 15?
Yep.
2 over 5?
Absolutely. Absolutely. So, right, there's multiple paths to get there, but ultimately, you should still get to the same place, where you have a 7 on top and a 15 on the bottom. How you get there is up to you. I showed you the way that I chose. You absolutely could have reduced the 6 and 15. You could have done the 15 and the 21. Okay? Lots of different paths at the end. So long as you get to here, I don't care what path you choose. Okay, now let's look at the variables. I like to go in alphabetical order because typically we write stuff in alphabetical order anyway. So let's start with the A. I've got an A on top, A to the third on top, and an A on the bottom. So there's more A's where? On top. How many more? Okay, so there's my A squared. Okay, next in the alphabet comes B. And there's only a B squared on the bottom, so I don't have to worry about canceling anything. Next in the alphabet is X. More X's on top or bottom? How many more? And what about the Y's? They cancel out. Is that it? How many had that? Now let's say you didn't have it quite in that form. You had it x to the third b squared. Is that right? Yeah, no, it's still right. But yeah, our preferred way to put it, we prefer to put them in alphabetical order, but you don't have to. I'm not going to get so hung up on that, but get in the habit of doing that. As you continue to move on and advance in your math life, that's going to become an expectation, okay? Any questions? Do another one. Now, I already, for the sake of time, I already changed, flipped. So this was division. Okay, keep the first fraction, change from division to multiplication, flip the second one. Okay? Because again, we want everything to be a multiplication problem, and then we can do our reducing like we did before. So go for that one. Oh, here we go. I am first going to take care of the 7 and the 21. That gives me a 3. 8 goes into both of those. So I like to take care of the numbers first. There's nothing else I can do. So on top I'm going to have a 2. On bottom I'm going to have a 9. Okay? Again, I like to go alphabetical order. So I've got a squared and a to the 4th, which gives me a squared on the bottom. I've got b squared and b to the 3rd. So that means I have a b on the bottom. Let's see. I've got an m and an m to the 3rd, which gives me m squared on the bottom. There is not a t squared anywhere else. There is my final. How many got it? Okay. Any questions? Pretty good. All right, let's look at some groups. Ones with some groups. Again, I've already changed it for you for the sake of time. Whenever you have a division problem, we want to turn them into multiplication problems. Keep, change, flip. What do we do now? Can I cancel any of these groups right now? These are all groups because they're trinomials, they're binomials. If the groups were able to be canceled right now, you could. So if I had an x squared minus 9x plus 20 in the bottom of either one of these, I could cancel the whole thing. I can't in this case. So you're going to have to what? To do what? Factor everything completely, and then you can try to cancel groups. Go. So I completely factored it. All tops, all bottoms. Now that it's factored, we look for groups that can cancel. Don't cancel. You can only cancel a group with a group. So for example, I have an x minus 4 and an x minus 4. I can cancel those out. Identical groups cancel out. Tops and bottoms still. Okay? I also have an x plus 7 and an x plus 7. Cancel those out. Identical groups. Do not attempt to cancel a 6 with a 3. 3 is inside of a group. It's sort of protected by the group. 6 is a loner. It does not get to invade the group. Okay? Some of you tried to do that on the last quiz or test. Alright, make sure that we don't do that. Now, that's it. That's all I can do. So on top I have a 6 times x minus 5. And on bottom, just for preferred method, okay, write it as squared. You don't have to write them times each other. And then you don't have to multiply them out either. Just leave it like that.